Welcome to today's Explainer. We are going to engineer a complete start-to-finish architectural blueprint for building automated, AI-driven financial auditing software, right from the ground up. You know, the financial landscape has fundamentally shifted, and honestly, traditional infrastructures are just struggling to keep pace. So today, we're going to design a system built specifically for the realities of 2026. Let's get into it. Here is our blueprint for today. We've got 6 critical steps on the agenda. We're looking at the 2026 Audit Challenge, ingesting real-time financial data, integrating with ERP systems, building the AI intelligence, securing immutable audit trails, and finally, selecting the tech stack.
Kicking things off with Section 1, the 2026 Audit Challenge. To understand exactly what we're building, we first have to recognize the massive data explosion that has, quite frankly, completely broken traditional systems.
So with the exponential growth of financial data, we really have to ask ourselves, is manual auditing dead in 2026? Is a process that relies on slow, inefficient human labor and manual cross-verification actually done for? Let's face it, relying on caffeine and late nights staring at spreadsheets, that's just not a scalable solution anymore. When transaction data gets this large in scale, this diverse in type, and so highly time-dependent, human auditors can only really focus on high-priority areas. And you know what that means? Less than optimal accuracy. The sheer volume literally outpaces what manual capabilities can handle.
Now consider the digital disruption we're seeing across, well, all industries. Tom Goodwin from TechCrunch hit the nail on the head. He said, Uber, the world's largest taxi company, owns no vehicles. Facebook, the world's most popular media owner, creates no content. Alibaba has no inventory. Something interesting is happening. And he's totally right. Old models of operations simply cannot survive in a new ecosystem where companies are building entirely new products using real-time data streams. The financial audit sector is experiencing this exact same systemic shift. It's fundamentally changing what it actually means to verify and secure transactions.
So what's our ultimate goal here? It's not just taking paper audits and putting them on a screen. We are building true autonomous finance. This means fintech engineering that encompasses agentic AI, real-time ISO 2022 data standards, and instantaneous settlements. We are constructing an architecture that completely moves away from traditional, clunky batch-processed reporting.
Which brings us to Section 2, ingesting real-time financial data. How do we actually feed this beast? Let's start laying our foundation by looking at how we pipe that sheer volume of transaction data straight into our system.
Real-time data ingestion is the process of capturing and storing data from various sources for processing and analytics almost instantaneously. We are totally avoiding the delays of traditional batch processing here. The absolutely crucial point is that we must capture financial events the exact millisecond they occur. If we want an AI to make split-second risk and fraud assessments, that data has to flow continuously, like a stream from the generating source right to final consumption.
Let's look at the actual pipeline. When comparing ingestion tools, using an architecture like Redpanda gives us up to 10 times lower tail latencies than Apache Kafka. We're looking at benchmark data latencies of 13.91 milliseconds for small workloads. That is insanely fast. And for data volumes, this allows us to hit that golden rule of data engineering, targeting 80% theoretical sustained throughput capacity per cluster. You're getting much faster performance without needing to rack up additional hardware.
Moving right along to Section 3, integrating with ERP systems. Now that we've got our real-time data flowing seamlessly, our next architectural layer is securely connecting our audit software to massive enterprise ERP systems.
When you're connecting to systems like NetSuite or QuickBooks, you've got to be smart about it. You must systematically plan your API integration following these 3 steps. Step 1, prioritize via scoring framework to figure out the impact. Step 2, loop in your go-to-market and sales teams so they actually understand the value proposition. And Step 3, strategically decide to build versus buy based on your engineering resources. Trust me, you do not want to drain your team on endless maintenance.
Speaking of maintenance, let's compare native integrations against unified APIs. Trying to scale native integrations with an internal build is just notoriously difficult. It requires massive engineering upkeep for every single new system you add. That's why unified APIs like Merge Dev are an absolute game changer. With a unified API, one single API build lets you access dozens of ERP systems instantly. It's the most efficient way to sync invoices, expenses, and ledger entries directly into our pipeline, effectively solving the entire scalability challenge.
All right, this leads us to Section 4, building the AI intelligence. This is where it gets really fun. Now we get to the brain of our operation, actually installing the AI models that will perform the automated auditing. Listen,
To build a trustworthy financial AI, you absolutely cannot just plug in a basic chatbot. No way. You must construct a multi-layered AI agent. Think of it like a stack. You need an orchestration layer to manage agent workflows. Then, a tool layer that connects to your APIs and core systems. Below that, a knowledge layer grounded in your structured data using Retrieval Augmented Generation, or RAG. You also need a policy layer to enforce strict regulatory guardrails. And finally, a monitoring layer to constantly track performance and model drift.
And the impact of these specialized agents? It is massive. In production right now, we are seeing systems deliver up to a 70% reduction in manual ticketing. 70%! And when it comes to speed, these agents are executing complex fraud anomaly detection in less than 50 milliseconds. That is sub 50 milliseconds to stop something in its tracks. That's real-time risk prevention, rather than just post-event remediation.
But hey, speed isn't our only metric here. To pass strict SOX compliance regulations, we have to overcome the classic black box algorithm problem. We must leverage explainable AI, or XAI. This ensures that every single automated audit judgment comes with a clear, human-readable justification. Because at the end of the day, regulators and human auditors still need to clearly understand exactly why a transaction was flagged.
Which perfectly segues into Section 5, Securing Immutable Audit Trails. To guarantee that those lightning-fast AI decisions and data logs are completely tamper-proof and verifiable, we've got to build our security vault.
Now, what's really fascinating here is the stark contrast between traditional incident management and blockchain-based features. We're talking about the difference between vulnerable centralized databases and the absolute data integrity you get from a continuous, immutable blockchain ledger. Traditional systems rely on manual tracking, which means potential gaps and human error. A blockchain-based system, on the other hand, offers automated, continuous recording governed by smart contracts. It drastically improves accountability across the board.
When you execute this workflow using smart contracts within a zero-trust architecture, the timeline is just revolutionary. Look at this. At 0 milliseconds, you have automated incident detection. By 50 milliseconds, you've got cryptographic validation via consensus. At 1 second, an immutable ledger update happens via a smart contract. And in just 5 seconds, you have real-time compliance reporting. Our software detects, cryptographically validates, and permanently locks an audit trail into the ledger in literally a matter of seconds.
Finally, we arrive at our last step, Section 6, Selecting the Tech Stack. To make this entire architectural blueprint a reality, we must select the exact programming languages and frameworks required for a secure, 2026-ready deployment.
We really need a polyglot approach here, because honestly, no single stack does it all. We use Golang for our secure high-throughput microservices, because its key strength is handling over 100,000 transactions per second with minimal memory overhead. Then, we pair .NET and Azure for core banking and regulated workloads, which gives us a bulletproof environment through confidential computing and strict compliance. And finally, Node.js. We use that for real-time event orchestration and AI, since it maintains thousands of WebSocket connections to deliver instantaneous notifications.
So, as you look at your own infrastructure today, I want you to ask yourself this final question. If your audit software isn't autonomous, explainable, and immutable, is it really ready for 2026? Because in 2026, we aren't just digitizing audits anymore, we are actively engineering autonomous financial trust. If your system can't act intelligently, explain its reasoning, and completely secure its footprint, it simply isn't ready for what comes next. Thank you so much for joining me on this explainer.